Auparavant, nous devons entendre Mikkel Wallentin, qui vient du Center for Semiotics and Functionally Integrative Neuroscience de Aarhus University au Danemark. Et le titre, donc, What is it to you? Spatial Perspectives in Language and Brain.
Thank you. Thanks to the organizers for inviting me, and I do apologize for not being able to present this in French, but I think you'd be better off if I said in English. In Danish, at least, we have a notion that the eyes are the mirrors of the soul. I don't know if you have something similar in French, but I think so. It seems to be a common thing that we acknowledge that we can learn about things by looking people, learn about other people by seeing into their eyes and seeing where and what they are seeing. But this there may be more to this than just that, and I'll try to entertain the possibility that this is not just a metaphor, that there's actually parts of the brain that are involved in mirroring the souls of others, and that those perhaps also have to do with our eyes. Before I get to that, I just, because of the mixed audience here, want to give you a brief introduction to some of the things that I've been working with. And my primary topic of interest is language and language comprehension. And if you look at textbooks on the neural underpinnings of language, you'll find in all of them that we're supposed to have two primary language centers in the brain, one which is green, which is involved in language production, usually known as Broca's area or Broca's area, I suppose we'll pronounce it today, and another one in the temporal cortex here, the red one, which is supposed to be involved in language comprehension. And as I said, language comprehension is my main interest, and we could ask the question, why would this exact area be involved in language comprehension? And if we look at this child on the screen here and imagine how this child might learn a language, there's only, in my view, one way that can happen, namely that something comes into the visual field of this child. This might be it at some point, and then this image or perception is transferred to the visual cortex, and at the same time this child then might hear a sound, and if it's an English-speaking parent and child, this word might be dog, and this sound is then transmitted to the auditory cortex, which is located here, and you can see it in blue up here. And if we have a very naive, and I have a very naive theory about how brains work, we might imagine that this information is then sent out through the cortex. It spreads, you could say, and at the same time, exactly because they're presented at the same time, then another signal from the auditory cortex will also spread, and at some point they'll meet, and this is where an association will then be formed. And this is perhaps where then the memory of this association is located. And if we believe that it's as simple as that, it's probably not. But then we might start asking, okay, if what we learn are these associations between visual input and auditory input, then we might start investigating what happens to the visual input in the first place, because it might not just be processed here, it might actually go other places. And we know from a lot of work on visual processing that there are two primary streams of processing. One is known as the ventral stream. It is primarily involved in object recognition and objects, and the other one is known as the dorsal stream, going up here primarily, and it's involved in knowing where things are, you could say. And in language we have something similar to that, namely that we have sentences that have a whole meaning, like the motorcycle is in front of the church, and you could say that the what's of that sentence are the motorcycle and the church, and then we have this grammatical structure here, which is almost meaningless, except that it sort of puts these things in relation to each other. So it is in front of it, and we might get such a picture here. Right, so if we think that associations are built wherever information streams meet, you could say, we could imagine that some of this structural or grammatical or spatial structure in language somehow meets the information from the visual system in these where regions of the brain. This is also known as the overlapping systems theory. So where is this dorsal system? Again, this is a monkey brain, and there are three main players in this story. Only two of them will be dealt with today. There's this parietal region, which is thought to reflect what in humans are called precuneus or BA7, and then there's this region, and that's where the eyes come in to the picture. This is a region known as the frontal eye fields. They're involved in producing eye movements, and Professor Berthoz will know a lot more about that than I do, but we'll return to this region after we've dealt with this other region. Okay, what I've done is that I've placed people in this environment and introduced them to strange stimuli that have to do with looking at images or looking at sentences, and then afterwards answering questions about the contents of those stimuli. So here is one study that I did. We showed subjects images like this that have three what objects: a man known as he or him, and a woman known as she or her, and a chair known as it. So what we could then ask was two kinds of questions. One that had to do with the spatial layout of this image, like was he in front of her? So we showed this image and then we removed it, and because we wanted to have an image of the brain's activation while not looking at anything. So these are questions presented through headphones, so that if we get activation in the visual system, then we know that it's not related to direct visual stimulation. We could also ask questions that had to do with non-spatial relations, such as was he older than her? And we could place this in an egocentric viewpoint. So was he in front of you, meaning when you look at this image, was it in front of you or to the sides? If we take the two spatial questions and contrast those with the activation that evoked by the non-spatial questions, we see that it is exactly this dorsal part of the brain, that is the upper part here towards the back, called again the precuneus, which is the most active when you are asked to recall whether something was in front of something else, or whether it was in front of you or not. Further, what we found was that in this region, people who were good at this task, those that had the shortest response time, and they were also those that had the most correct responses, had a greater response in this region compared to those that were less efficient. And then, because this region is known to be doing a lot of things, and we want to be very sure that we'd actually found what we thought we'd found, we did another kind of analysis, and I'm sorry for these ugly lines here, but this is meant to illustrate a hypothesis about how the brain actually works. So we might imagine that a signal from somewhere in the brain looks something like this, but it might look different if the task is more difficult. So we might expect to get a stronger response, and again, if the next task is then easy, we might again expect to see a lower activation. So within the same subject, we might expect to see variation as a function of how difficult this individual question was. And we measured that in terms of response time again. And then we had a secondary hypothesis, namely that if you're a good performer, then we might actually expect to see a lower activation because you're being more efficient when the task is easy. But when, for some reason, the task becomes difficult, we want to see a stronger modulation as a function of task difficulty. So we expect to see these types of variation within and between subjects. And to give an example from the same study, we could take the language region here, that's a Broca's region, and look at how that relates to those two theories, or hypotheses that we just proposed. And what we see is that when we combine these two hypotheses, we see that those that are very good, they modulate their responses more in this region, both when they hear or when they respond to the spatial questions and when they respond to the non-spatial questions. So this region doesn't care about whether it's spatial or non-spatial, but it cares about how efficient you are in answering these questions. If we then look at the precuneus here, we see that, again, the good subjects, they tend to modulate this region more as a function of task difficulty than the poor-performing subjects, but only in the spatial paradigm. So in the non-spatial context, they actually down-regulate their activation compared to those that are bad at this task, and that's perhaps why they're bad at it. So all this points towards there being such an overlap between systems. So here we can see the effect of actually watching the picture, and you can see that in this region we have a strong response from watching the picture. And if we then look at the response from recalling the spatial properties of the picture, again we see a response here, but not from recalling the non-spatial properties. So this looks like an overlapping system. We wanted to check then whether this was just something that happened when you recall an image. And to do that, we made an experiment, a pure language experiment, where I came up with these very poetic sentences that had both a spatial content and some non-spatial content. So this was in Danish. Here's the translation of an example. With the front against each other stands a fat elderly man and a red-haired girl. And after reading this sentence, it was displayed on a screen. Again, through headphones, subjects were presented with questions, one that was spatial and two that were non-spatial. And if we compare the response from the spatial task to the to non-spatial task, we see a very, very similar pattern of activation. So this again points towards an overlapping system. And if we look at the overlap between those two studies, this is what we get. So the first conclusion is that verbally cued recall of spatial language content recruited the same network of brain regions as verbally cued recall of spatial information from an image. So where in language processing seems to be equivalent to some degree to where in perception in terms of the bold signal, which is what we measure with our scanners. So this is consistent, at least, with a theory of overlapping systems. Right. But if we look at the picture here again with the overlap between those two studies, something that struck me with these two dots here, and they may or may not be the same as the frontal eye fields. They might be a bit too superior to be too high up. We would expect to see them down here somewhere. But this is where the story about the eyes come into the picture. So in the literature, you can find something called the cooperative eye hypothesis, and I like that very much. And it says it's hypothesizes that actually the reason that humans have this white in their eyes is to make it easier for other people to follow our gaze. And it's just so happens that none of our con species have this, probably because they are not as cooperative as other species. So it might not be an advantage to this monkey to tell its fellow monkeys where it's looking, because if it's more of a competitive type of animal, then if it has its eyes on a particularly nice piece of fruit, then it better not display that, because it might not get it. So this is, in a way, the same as saying that the eyes are the mirrors of the soul. We want to display where we are looking because we want other people to know where we are looking, so that we can share our world with them. So this could be called simulation theory. We understand the mental states of others on the basis of our own mental states, and we understand the states of others by looking where they are looking. So mentalizing, as Chris and Uta Frith calls it, could be related to, or probably is related to, simulating other people's position and gaze. So again, we might hypothesize that regions in this dorsal visual system subserve these kinds of reconstructions that have to do with where people are looking and how to put ourselves in their shoes. So this brings us back to the study where people saw this image, and to this comparison between a so-called allocentric spatial relationship and this egocentric relationship. And this is not terribly easy to compare, because it's actually a lot easier for people to take their own perspective than it is to take other people's perspective. So there are some task difficulty differences that we had to deal with. But in order to, again, be very conservative and only say stuff that we actually believe in, we started out by, again, taking this space versus non-space contrast here, and then take the contrast between the allocentric spatial questions and the egocentric spatial questions here, and then take the activity from the allocentric spatial questions relative to a rest baseline. And then these three contrasts we collapsed so that we had one overlap. So only images, only activation that was in all three of these were used. And in that region, again, we found that certain regions had a strong activation in this region, had a strong relationship with performance in this task. So this time this is between subjects. This time performance is towards the right. The better you are on this task, again, the more activation you have in both of these regions. Yes. So because all of these contrasts or analyses point in the same direction, we claim that the frontal eye field seemed to play a role during the construction of frame of reference or viewpoint in working memory content. And remember that these are regions that are involved in eye movement, but in this task there was nothing to look at. The screen was empty. And we also did eye movement control in some of the subjects in this study, and they didn't move their eyes. So we believe that this has to do with the task and not with task-relevant stuff. Yes, and this is then consistent with these kind of simulation theories that suppose that when we imagine stuff, then we do as we would do in real life to some extent. So if we want to move ourselves to the position of others, one of the things that we have to move with is our eye gaze. But if it's only in our imagination, then we still do some of the preliminary we still have some of the preliminary brain activation that we would have if we did this in real life. Yes, and I would like to thank my collaborators from Aarhus and from the UCL, and thank you for your attention.